Zach, can you do this? Miraj, Ahmad.
Yes, sir. I just joined, sir, so I'll just try.
We just started the preparation of carboxylic acid. We did this preparation in the previous class, first and second.
Okay.
And the third is preparation of carboxylic acid from nitriles and amide. So this is your nitriles. So in this nitriles, you are going to react this with H2O in the presence of acid and base. You will get amide, and after this, you are going to heat it in the presence of acid or base. Then you will get this RCOOH.
Okay.
And as a byproduct, you will get amine, NH3. So I just gave a question. Please write the IUPAC name of the B. Zach, please do let me know when you are done with this. So I'm going to explain it. You are taking a lot of time. So this will be CH3, CH2, and this cyanide will be converted into amide, RC double bond O NH2. After using this will be broken, and hydrogen will be added here, and OH as well, H2 in the presence of H2. As you know that this will have negative and this will have positive. So negative will go to positive and positive will go to negative. And in this way, you can see this will be your CH3 and then CH2. And then it comes C double bond OH. And your byproduct will be again amine. So basically, this is how we prepare carboxylic acid from nitriles. And if you need to prepare carboxylic acid from amides, only this step is enough. Because if you are going to prepare carboxylic acid from nitriles, we need to convert this nitrile into amide, and after this amide, we will get carboxylic acid. Zad, are you there? Alan?
Yes, sir.
Okay, thank you. Alan, Madam.
Yes, sir. B
Am
is
I on?
butanoic. Yes, sir. B is butanoic acid.
I couldn't hear you. Can you repeat it again?
Yeah, so B is propanoic acid.
Am I on? Just wait for a minute. I'm changing the because I'm not getting network. Zaid, are you there? Okay, Zaid, am I audible? Hamad, am I audible?
Yes, sir, you're audible. Slightly, sir, but
Am
it's
I
not
audible?
clear. Still not clear, sir. You're audible, but still not clear for me.
It will be clear soon.
Sorry, sir.
It will be clear now because I was on ground floor because there is a work going on. That's why electricity is cut off. Am I clear now?
Yes, sir. Yes, sir. Now it's okay.
I just turned off my video because the power is cut off. Okay, is that clear? Yeah. Will that be okay with everyone?
Yes, sir.
Alan,
Yes, sir.
thank you. Let's. So everyone done with this? Can I move to the next part?
Yes, sir.
Okay. Now see, we just prepared carboxylic acid from nitrites. Now we are going to prepare carboxylic acid from amides. Amides. So can you change this to amide? Please do let me know the name of the IUPAC name of the product. Zed, you are not responding. Yeah, I'm going to explain.
Hello.
Yes, Zed.
Yes, sir. Am I audible?
Yes, yes. Now you are audible. Can you do this reaction? Okay, let's see. This will be directly converted into CH3COOH. What happened here? It's very easy to understand. This was CH3, C double bond O, and this is your NH2. Now this H3O positive has two parts, H plus and OH minus. Now you also know that this will have negative sign and this will have positive sign. So positive will get negative and negative will get positive. So in this way, this bond will be broken and it will form CH3C double bond O, OH. And as a byproduct, you will get NH2 plus this H. This will be basically NH3. Is that clear to everyone?
Yes, sir.
Can you do this? So it is basically ethanoic acid. This will be also in the same way. You just need to put carboxylic acid at the place of CONH2. How the reaction took place? It's very easy to understand. This is your C double bond O and this is your NH2. So what happened here? So this will be broken and OH will be added here and you will get, and H will be added here. H plus will go to this and OH minus will go to this. And NH3 as a byproduct.
So how we'll know whether the oxygen is single bonded or double bonded?
Where?
In the
Are you talking?
CO, yeah, this one.
Okay, see, it's very easy. Nitrogen is making already two bonds, right? So it will make single bond with carbon, yes or no? Because my nitrogen makes three bond. Fourth bond will be your basically coordinate bond, yes or no? Now you can see this carbon is connected with this carbon with a single bond, and this is your benzene, whatever this part, and oxygen is here, so it will be making double bond because of carbon makes four bond. Please do let me know when you are done with this. Are you done with this?
Yes, sir.
Yes, sir.
Okay, thank you. Now, the next preparation comes from From nitriles we just did now, from Grignard reagent, from Grignard reagents. So if you are going to do from Grignard reagents, you are going to react this Grignard reagent with CO2, and you know CO2 is like this, the structure is linear in the presence of dry ether. Since Grignard reagent is highly reactive, so we do this reaction in the presence of dry ether. Now what will happen? It's very easy to understand. This will have basically any one of oxygen will have negative charge, so it will be basically like this. First I'm going to write it and then I will explain the mechanism, not the mechanism basically. And after doing hydrolysis, you will get RC-OH, carboxylic. Now, as you can see, this is your RMGX, right? And this is your C double bond O, double bond O. And you know that oxygen is more electronegative, so it will take electron from carbon. So this will have delta positive and this will have delta. Again, this is your positive because it is a metal, and this is non-metal electronegative, it will have negative. So as you can see, this negative will go to this. One of the bond will be broken. So as you can see, C double bond O. You can see C double bond O, and with C there is R. So this R comes here, and with O minus, Mg plus will go. So in this way you get it. Now if you got this intermediate like a structure OMg plus X, after reacting with H3O positive, that means H plus and OH minus. Again, what you are going to do, this will have positive sign and this will have negative sign. Because carbon is less electronegative, oxygen is more electronegative, so it will attack here, and you will get RC double bond O, OH. And what will be the byproduct? This H plus will combine. So it will be MgHH. Okay, the byproduct. Oh, wait a minute. This OH minus. Okay, okay. H plus. Okay. Wait a minute. Let me clear it. This will have positive. So MgOHX comes. MgOHX. MgOHX. Because oxygen is already there, so this hydrogen combined with this OH and X was there. So this is your byproduct basically. We just need to focus on the main product. Please do write it. Mehraj, are you able to see the screen?
Yes, sir. Now I'm able to see the screen.
Let me know when you are done with this, everyone. This is the fourth preparation. Now we are going to deal with just fifth and sixth. Then our preparation will be covered. Everyone done with this?
Almost done, sir. Just 1 minute. Done, sir.
Very good. Now the fifth preparation is from basically acyl chloride and anhydride. From acyl chlorides and anhydrides. This is your fifth preparation. Now, as you can see, this is your acyl chloride, and if you are going to react this either directly with H2O, you will get RC double OH plus Cl minus. And if you are going to react this in the presence of base, you are going to react this with H2O in the presence of base. You will get first RC double O minus and Cl minus, and then again going to react with acid H3O positive. Then you will get RCOOH. How does this reaction take place? So as you can see, this will be basically your RCOOCl, and H2O has two parts, H plus and OH minus. H plus and OH minus. So basically this will be the positive sign, positive side, or this will be negative sign. So it will be attacking here, and it will form RC double bond OH. And in the next, in the same way, OH minus will attack here. As you can see, this is your, for the second, this is Cl, and you are going to react this with OH minus in the presence of H plus. So this will be your positive sign, and this will be a site, or this will be negative site. So it will attack here. So it will form RC double bond O. And you can do that. Wait a minute. You can do, this is slightly difference, not much difference. Let me show you. So this will be your, this was Cl minus. So what happens here? It's very easy to understand. It will go with this electron and it will form O minus. From water, oxygen will attack here, and this will be O minus, and after reacting with H plus in the acid, it will go there and it will form RCOOH. So the mechanism is almost same. What you need to do, it's very simple. Replace this Cl with OH and you will get carboxylic acid. I'm going to give you a reaction. Please do write it, and then I will show you. Are you done with this?
Done, sir.
Very good. So if I'm going to give you a question, CH3, CH2, C double bond O Cl, and you are going to do hydrolysis. Can you tell me the name of the product? Zeb, Meraz, Allen.
Yes,
Okay.
sir.
So what happened? This will be broken and OH. Replace this Cl with OH. What will be the name of the product? Propanoic acid. It's a propanoic acid, yes or no?
Yes, sir.
So it's very easy. Now we just did the preparation of carboxylic acid from this, what we say, from this acyl chloride. Now we are going to do this with anhydride, acidic anhydride, acid anhydride or anhydride. So if you have this C6H5 C double O CO CH3 and you are going to do the hydrolysis, what will happen? First, I'm going to write the structure C6H5 and then C double bond O and then O and then C double bond O and this CH3B. So what will happen? It's very easy to understand. This bond will be broken and the hydrogen will be added with oxygen and with carbon OH will be added. So what will be the product? C6H5 C double OH. In the same way, another product, another carboxylic acid, you will get CH3 C double OH because this is your CH3, this is COOH, and this is your C6H5 COOH. In this way, you get benzoic acid and ethanoic acid. So it's very easy to do the reaction. Benzoic acid, and this is your ethanoic acid. Please do let me know when you are done with this. Everyone done with this?
Yes, sir.
Okay. Now, if I'm going to give you a question on this, like as you can see, if I'm going to give you CH3, CH2, and then C double bond O, C double bond O, and CH3. Can you, if you are going to do the hydrolysis, can you tell me the product?
Start with CH3, CH2, C double bond O, O, C double bond O, CH3.
This is CH3 C double bond. This bond you are going to either break from here and you can break from here. You will get CH3, CH3, and add with O, you are going to add hydrogen. With carbon, you are going to add OH. So as you know that this will have negative and this will have positive sign, and H2O is H plus and OH minus. So OH minus will go to carbon and H will go to oxygen. So it will form OH, and another carboxylic acid you will get from this side, that is CH3 C double bond OH. So one is propanoic, another is ethanoic. Have you got this?
Yes, sir.
Everyone done with this? Please do let me know. Okay. Now the next is from esters. So you can see esters directly in the same way, acyl halide, anhydride, we are going to do hydrolysis and you will get carboxylic acid. In the way you can see, this is your benzyl benzoate, C double bond O, OC2H5. This is your what? This is your basically ester. And if you are going to do the hydrolysis, acidic hydrolysis in the presence of acid, you will get directly the carboxylic acid. So this will have negative sign and this will have positive sign. And this is your H plus and this is your OH minus. Now you know where is which one is going where. So this will be your the product, that is carboxylic acid, C double bond O, OH, that is benzoic acid, and you can see this is your negative that is going here, that will form alcohol, C2H5 OH. C2H5 OH, that is ethanol. And this is your benzoic acid. Okay. But we were preparing carboxylic acid, so this is your important reaction. Is that clear, everyone? This is your ethyl benzoate. Am I audible? No one is responding at all.
Yes, sir.
Yes, sir.
Okay, please do write it. There is another way to prepare carboxylic acid from this ester that we will see. Can I change the slide?
Yes.
Very good. Now see, if you have CH3, CH2, CH2, C double bond O, O CH2, CH3, and if you are going to react this with alkali, that is your basically NaOH, that means base. What will happen here? This Na will go directly to this because it will have positive sign, and this will have negative, and this will have negative, and this will have positive. So you can easily understand that opposite charges attract each other. So this will be the product you will get, C double bond O Na. This is basically your salt. As you know that this is acid or base, you can say this is your salt, and as a byproduct you will get an alcohol, that is CH3, CH2, OH. Now after the formation of this salt, you are going to react this with acid, that is H3O positive. So there will be proton transfer. H plus will replace sodium. So in this way you can get the carboxylic acid, CH3, CH2, CH2, and then C double bond O, and then OH. So you will get butanoic acid, and this is your ethyl butanoate. Wait a minute. Ethyl butanoate. Is
Screen is not.
everyone able to see the screen? Yeah, I know that. Thank you. Can you see the screen now? Okay. Please do let me know when you are done with. Everyone done with this?
Yes.
Okay. So here our preparation is completed. Is there any doubt regarding preparation of carboxylic acid from all of this method? Please do let me know. Yes or no? Okay. So we are going to start the chemical reaction or chemical properties of this carboxylic acid, and it is categorized in two parts. The first is basically reactions involving cleavage of OH bond. As you know that the structure of the carboxylic acid is like this. So we are going to study the chemical reaction, only the bond cleavage between OH. And after that, we will study about the bond cleavage of CO. So this is the first, and here we are going to study acidic nature of carboxylic acid. So as you know that when acid react with metal, salt and hydrogen gas form. So here reaction with metals and alkalis that stand for basically base. So you already know that acid plus metal, that will give you salt plus hydrogen, and you also know that acid plus base, that is alkali, will give you salt plus water. Now you can see, if you are going to react this carboxylic acid, this is your carboxylic acid, with sodium, you will get, you are going to replace this hydrogen with Na, and you will get a salt RCOO. Na will have positive charge and this will have negative charge, and hydrogen gas will be released. This H plus will combine to form H2, and you can easily balance it in this way. So this is your basically carboxylic salt, and this is your hydrogen gas. If you are going to react this carboxylic acid with a base RC double bond OH, then again salt will form, and how salt will form? This hydrogen will be replaced by sodium, so it will be RCOO, and again positive negative you can put, along with the formation of water. Please do write it. Then we are going to react this carboxylic acid with a sodium hydrogen carbon. Are you done with this?
Yes.
Okay. Now see, if you are going to react this RCOOH with NaHCO3, it's very easy to understand. Again, this sodium will be this hydrogen will be replaced by sodium, so it will be the salt Na, and this will be positive, this will be negative, along with the formation of H2O, and then again another gas, that is carbon dioxide, will be formed. As you know that this will be positive, this will be positive, and this will be in negative, CO3 minus 2. So, and here it will be positive. So, and COO minus, so this will go with this, and CO3 minus, so from here one oxygen will come and combine with this 2 to form this H plus, and this is H2O. It will form H2O, and this will form CO. It's very easy. With NaCO3, carbonate CO2 will almost always release. So if I'm going to give you a question on this, CH3, CH2, COOH, and you are going to react this with sodium hydrogen carbonate, what is the main product? Name the main product. So it's very easy, just replace this and you will get, this is your CH3, CH2, and then COO. This is the salt that you will get. Please do let me know when you are done with this. It's very easy. The chemical reaction of carboxylic acid is very easy. Are you done with this? So there, about conversion. Before doing conversion, you need to go through all the reactions of organic chemistry, and it will come. It will be easy for you when you are going to do a lot of question on that. There is no shortcut because there are questions in haloalkanes and haloarenes that are related from class 11. If your hydrocarbon or reaction mechanism of class 11 is good, then you can easily do that. So you have to look on the reactions of class 11th also, or either you can do, I can explain the reaction, and whatever you get the new reagent, you can write it and know more about it. Okay, everyone done with this? Please do let me know. Okay, now see, this carboxylic acid, whenever goes in water, carboxylic acids dissociate in water, dissociate in water to give resonance stabilized carboxylate anions and hydronium ion, that means H3O positive, hydronium ion. Now, as you can see, this is your carboxylic acid, RC double bond O, OH. And if you are going to react this with water, H2O, what will happen? It's very easy to know. From here, H plus will be released. So H3O positive, that is hydronium ion, and O minus will be there. This is your positive part. So from here, you can see how the resonance is taking place. RC double bond O minus, and then you can do the reaction like resonance like this, and this. Then it will be going the negative on this oxygen and double bond on this oxygen. So this is your resonating structure, and you can also write it like this, and negative. So please do write it. Are you done with this?
Yes, sir.
Very good. Now see, we are going to talk about acidic character or acidity. Acidity is basically directly proportional to the acid dissociation constant, which is inversely proportional to the pKa value, and also directly proportional to the minus I electron withdrawing group, and also directly proportional to minus R, the resonance with the molecules of the resonance that withdraw electron, inversely proportional to plus I, and also inversely proportional to plus R. So in short, you know that what is acid? Acid is basically electron acceptor or electron withdrawer. So if a group is highly electronegative or electron acceptor, that will be more and more acidic. If I'm going to give you a question like this, C double bond O, and this is your O, and there is a group which is EWG, electron withdrawing group. And electron withdrawing groups are lots like we can write electron withdrawing group fluorine, NO2. Wait a minute, it's not working. Like fluorine, NO2, more electronegative element CN, like this. And if you have electron donating group connected to this carboxylate anion, can you tell me which one is more stable? Stability, we are dealing with stability here. Can you tell me which one is more stable? The one
Withdrawing
with
group.
connected withdrawing group is more stable than donating group, because this negative sign says that it is electron rich compound. That means it do not require electron, and same for this. But with this EDZ is there, and its nature is to give electron. So it will continuously give electron, and this oxygen does not require any electron. So what will happen if it doesn't require and it is giving? So it is unstable. And as you can see, this is electron rich, so it can give electron, and it is connected with electron withdrawing group. So basically this is more stable than this, and also we can say this is more acidic than this. Electron donating group, like we can say alkyl group. So please do write it. Then we'll move to the next part, and I'll give some question regarding to acidic character. You have to arrange it. Are you done with this?
No, sir.
Okay.
Done, sir.
Very good. So I'm going to write a series. Now, which one is more electron withdrawing power and which one is less? So the effect, right, will the effect of following groups in increasing acidity order is. Phenyl lowest, then iodine, then bromine, then comes chlorine, then fluorine. Fluorine is most among them, and then Cn, and then NO2, and then CF. Now I am going to ask you, arrange them in increasing order of acidic character. The group with highest or most electron withdrawing group will be the most acidic in nature.
Sir, that CN is cyanide, right?
Yeah. You need to arrange this.
Sir, 23154.
2, 3. I think this is CF3, this is Cl3, this is Cl2, this is NO2, and this is your Cn. So CF3 is the most acidic, yes or no?
Yes,
Oh,
yes.
okay, sir.
Now this is 3Cl. Now this is 3Cl. So it will be always greater than 1 NO2, yes or no? NO2 is alone greater electron withdrawing power than Cl alone. But there is 3Cl. So it will be greater than again 2Cl. That will be greater than 1 NO2. So this will be the order. Are you getting my point? If 2Cl will come, then 1 NO2 will have lower power than 2Cl. Are you getting my point or not?
Yes, sir.
Yes, sir.
Please do write it and then arrange this. Just do this question. I'll be coming from Boston. Mehraj, are you there? Please do this. So let me know. Are you done with this? Ahmad?
Yes, sir.
So which one is more acidic in this? Let's take A, B, C. Which one is more acidic? Any one of
B,
you?
A, C, B.
No, okay, this is wrong. What about you, Zach?
Sir, CAB.
This is also wrong.
Sir, CBA.
Alan? If I will say it is wrong, then what you will say?
ABC.
See, NO2 is withdrawing group, and this OCS3 is electron donating group. So it decreases its acidic character, and there is nothing that will increase or decrease. Basically, there is no electron withdrawing group or neither electron donating group. So C is the most, and then B, and then B. B is greater acidic than A because it decreases the acidic character because it is electron donating. Is that clear to everyone?
Yes.
Okay.
Okay.
I'm going to change the slide and let's start the next reaction. That is reactions involving cleavage of COH bond. Now, first is basically formation of anhydride, or you can say preparation of anhydride. Formation of anhydride. So as you know that, I'm going to write a point about this carboxylic acid on heating with mineral acids such as H2SO4 or with P2O5 give corresponding anhydride. Give corresponding anhydride. So if you have carboxylic acid like this is your ethanoic acid, and this is the way to write the reaction to understand basically the reaction. I'm gonna write this like this, and this is your CH2. So if you are going to treat this 2 mole of carboxylic acid in the presence of acid and heat it, or in the presence of P2O5, so what will happen? It's very easy to understand. H2O will be eliminated, and then you can see anhydride is formed. Anhydride is formed. So this is this is how we prepare anhydride. I think that's very easy to understand, right? Please do let me know when you're done with this.
Yes.
Now the next you can look at.
Sir, wait.
Oh, no problem. Do let me know when you are done with this. Zahid, are you done with this? Zahid, Zahid is not there. Everyone done with this? Alan and
Yes, sir.
Aman.
Yes, sir.
Very good. Now we are going to do the esterification that you have already studied. When carboxylic acid is reacting with alcohol in the presence of acid, you will get esters. You have studied this reaction, that's why I'm direct writing it. Is there any doubt?
No, sir.
Okay, please do write it. Okay, I would like to ask some questions. Zab, did you write the previous slide? Zab, did you write the?
Sir, he is not here.
Wait. Okay, are you done with this? Zab, you are there, but not responding at all.
Sir, my internet is weak. It's disconnecting again and again.
Did you write all this?
Yes, sir.
Okay, I would like to ask some question regarding your batch. Am I audible to everyone?
Yes, sir.
Please do let me know from the second book how many chapters you have completed. Hello, Alken. Yes or no?
Yes,
Yes,
sir.
sir.
Alcohol, phenols, and ethers.
Yes.
Aldehyde, ketones, and carboxylic acid. That it is completed almost. So I'm gonna take it. Yes. What about amines?
No,
Amines,
sir,
no, sir.
not complete.
Amines. Biomolecules is this biomolecule in your syllabus or
Yes,
it
sir,
is
it's there.
deleted?
It's there.
It is there. Biomolecules. Okay. Polymer is not in this here, right?
Yes, sir, it's not there.
Yes, sir.
Okay. Come to the next, solid state. Did you completed it?
Sir, it's deleted.
It's not in your syllabus. It's deleted.
Yes, sir.
Solution.
No.
No,
In our
sir.
You
batch?
haven't done solution.
No, sir.
No, sir.
MEI
We
batch.
started with halo alkanes. That's why.
Wait a minute. After solution, which chapter it is? Electrochemistry.
Electrochemistry.
Yes, sir.
Did you complete this?
No, sir, we didn't complete anything from the first book.
1 minute, sir, because I think I have
Really?
assignments for that.
No, sir, we did
Because-
electrochemistry. We did electrochemistry.
Yes, sir, we
You
did
did
that. Because
electrochemistry.
yes, sir.
Chemical kinetics?
No, sir, we
Chemical
didn't did.
kinetics.
So surface chemistry is
Surface
deleted.
chemistry? Surface chemistry is deleted. Okay.
Read.
Can you tell me about the D and F block?
It is there, sir.
Yeah. P block is
P block
deleted, I
deleted.
think.
Yes.
Yes, sir.
P block is deleted. And can you tell me about the coordination compound?
It's there,
It is
sir.
there.
There,
It's there. So how many chapters do we need to cover? This amines, this biomolecules, and then solution. This is deleted. And you have done the electrochemistry, that means chemical kinetics we have to do, and then D and F block we have to do, and then coordination compound, right?
Yes. Sir.
yes.
Oh my god, we have 2 to 4, 5, 6 chapters are there to cover. So see, this Friday I will not be able to take the extra class, and the previous Friday I was busy with other class. But the after this Friday, every Friday I'm gonna take extra class, because it's very important to take extra class in order to cover the syllabus till mid-January. Are you getting my point?
Okay, sir, but if you just notify us the timing, sir, because I have one more tuition on Friday, that's why.
See, we will basically discuss the on this Wednesday. I will tell you the timing for Friday. Are you getting my point? This Friday we can't have class because I will be traveling. Okay,
Okay,
but
Okay, sir.
I will notify all of you.
okay, sir.
Okay, so let's get to the next chemical reaction, that is reactions with PCl5, PCl3, and SOCl. It's very easy.
Sir, esterification we didn't complete it, right?
Yeah, we completed, because you have already studied it in the alcohols also.
Oh,
When
okay.
carboxylic acid react with alcohol in the presence of acid, you got ester. There were other methods to prepare ester. Like if you are going to treat this alcohol with acidic anhydride, then you also get this. Are you getting my point?
Yes, sir.
In class, basically in alcohol chapter, you have seen alcohol react with acyl fluoride in the presence of pyridine and all to prepare to produce this ester. That's why there was only 1 point, and I also only written the 1 point. Okay,
Okay, sir.
because this reaction you have covered in alcohols. So can I change? Can I go to the next topic? Yeah. So this RC double bond OH is going to react. If it is going to react with PCl3, and if it is going to react with, oh wait a minute, PCl5 first, because with PCl3 we are going to take 3 moles, and with PCl3 and with SOCl2, it's very easy. The reaction also given in the inorganic chemistry, that is P block. So in this you can see RC double bond OH will directly converted into RCOCl, and then POCl3 along with HCl. I will explain it how this comes. And with PCl3, 3 moles of RCOCl and H3Q. It's very easy. H3Q. I will explain it. And then with this, you will get the same product SO2 and then HCl. Please do write it. In the next class, we are going to start amines, right?
Yes, sir.
Sir, for Friday's examination, sir, for solutions from where we can practice, since we didn't do this in the class, so textbook will be okay, or Any suggestions which you give?
Yeah, you should go with the textbook first because
Okay.
NCERT is very important. You need to cover.
Okay.